Yeah, hello everyone. So last class we work on this award we did. We work on simple linear regression. Okay. So from there we did some various calculations on simple linear regression, but our result was not the best. So now we need now to continue on what multiple linear regression to see if really our result is going to improve. So on multiple linear regression, we are going now to add instead at this point of x. This is where we have that difference. At the point of x, that we use only the advertisement for the TV. We are going to use now advertisement for TV, radio, and newspaper. Should be at this position of x. So now let us start back. Let's say lesson 3 on machine learning. So our letter is on, we are on multiple linear regression. So you run it, just copy. Now we come here, since we did this other one also, we copy this. Yes, I wanted to see how where the changes take place, the difference between this one and the last one. Okay, the linear regression and the multiple linear regression. So you should see the difference. Okay, we come here, we create the data, creating this data, create this data. That was done. Then after creating this data, what do we do? This is where we have that changes. Now open your eyes, you see where the changes on multiple linear regression. So you copy this, only this one, add it comma. Okay, then copy this also. Yes, copy and paste should be a friend. Okay, so we have x is, now we have TV advertisement, radio, we have newspaper. Okay, run it. Then when you run it, we have again. Now after that, what do? We fit the regression model. Just copy the regression model. This one does not change. Okay, this one does not change. This one does not change. We fit the regression model. We call model equals to linear regression. Fit model to fit x and y. So our x now is the whole of this one and our y. So at this point, it is radio and news data that has added. Okay, so what is linear regression? Okay, now what next? Look at it again. What next? Now after feeding now that regression, we have to make the prediction. Make the prediction on x. Are we together? Make prediction because we are predicting the x variable. Okay, so we are making prediction on x. Y predict equals to model to predict x. Are we there? So now after when we did that, we now need to do what? We have to print the coefficient, the various coefficient. So you will see the difference. We are going to compare this coefficient with the new one that we are going to predict. Okay, so predict now the coefficient. Okay, now when we look at the intercept is 1.855 and the coefficient is 0.06. So let's look at this one. What was his intercept? His intercept was 7 point this and his coefficient was 0.0. Are we there? When you look at this one, his intercept its intercept is 1.855 and its coefficient is 0.06. Okay, then let's move forward. Let's move forward and print the performance metrics. Print the performance metrics. So we have the mean square error is 2.1. So we have the R square is 0.9. Look at this other one very well and clearly. Now our mean square error here was 9. The mean square error was too big. Okay, mean square error here is 9, and why our R square is 0.6, too small, because I said last class that the R square, the mean square error should reduce. If the mean square error is 0 point something, it is a very good news. Okay, but now look at our mean square error was 9, so the error is too large. Okay, so now our R square is 0.6. R square now is too, when the R square is close to 1, it's a good news, but not 1, because when it is 1, it's a problem somewhere. It cannot be exactly 1. It cannot predict, because it is the machine that is predicting the cell that, okay, if we have this, what will be the cell if we do this advertisement? Okay, if we sell 10,000 today, if we do advertisement, what will be the sale? So you cannot have the same 10,000. The machine can tell you that you can have 9,000 something, but not 10,000. But if now you have this, is a problem. So at this point now, we are looking at multiple linear. Now we use what the various. If you look at, we use multiple linear TV, radio, newsletter. So at the point when we use now all these various elements to predict only say we have good prediction. If we use this television, radio, newsletter to predict ourselves, it's more better than for you to use just only one. Yes, that is a proof. It's more better than for you to use only one. So we are going to go move again for you to see. Like if you see this is just showing the truth, because the mean square error here is 2 point. It's very small than the other one. The other one was 9 point, and the R square here is 0.909. Obviously mean that is good, but the other one was 0.6. Okay, it's showing that our prediction will be better than the other one. Are we there? Yes. Let's move forward. So we have this because we have never changed our plot, the scatter plot. The against TV is TV, radio, and newsletter. Copy here and paste it at this point. Okay, TV, radio, and newsletter. Okay. Yes, so at this point now, since we are drawing out the scatter diagram, so when we run this program, we have the scatter diagram already showing the cell. Now the cell now, at this point, we have what the TV, radio, newspaper. Okay, now these are the various colors. TV has blue, radio has green, and newspaper has red. Okay, I've written this code on what to display the prediction versus actual sale. So I wanted to know now the prediction with the actual sale. So we run it now. I see, okay, the actual sale, this is actual sale, right? It was 22.1. For actual sale for A, 22, B is this. So now the predict sale, this is what the machine has predicted. Are we there? Is 20.7. It's closer to the actual sale. Actual sale, very good. Okay. Now, if you look at 1, we have 10.4, we have 10.9. you have 9.3, you have 9.1, you have 18.5, you have 17. So this is a perfect prediction. Okay, obviously mean that really our we need to do what to combine the the TV advertisement, the sale. That is, we combine this advertisement using the TV, using the radio, using the newspaper in order for us to have this sale. So the combination of this will give a good sale. Are we there? So if we use only TV, we are not going to have a good sale. So if you combine these three, so this other one has high influence on the sale. Are we together? Yes. So when we have this, now we move on. Now we visualize the actual versus the predicted sale. We wanted to see it on the diagram. Okay. So we run it. So at this point now, this is the predicted sale and this is the actual sale. Are we there? So it's obviously showing that it is having a good line of fit. So at this point, when now this they correlate on this line, as I'm moving the same ordered point of this line, it's showing that what there's a good fit. Are we together? But now if it was far away from this line, if all this happens to lie on top of this line, at least from the starting right up to the end, I will it will be showing that what our our square value at that point, our square value will be 1. If our square value is 9 point, it's not possible for we us to have this diagram for it to lie straight. But if our square value is 9, is 1, obviously mean that the actual value and the predicted value will lie on this our line, your best line of fit, or this line straight. You understand me? Yes. So we need to consider to bring the equation of a simple linear regression. So on this equation, we have the simple intercept. This is our intercept. I have it from above. The simple coefficient of TV of the advertisement using the TV. We have 0.633. Now we have print simple linear regression equation. So let us run this thing first. Now this code tells us to print simple linear regression. That is why I bring it. Now the second line now tells us that print sale equals to simple intercept with the decimal places of 2 plus the simple coefficient with the decimal place of 4 times now the advertisement TV. So at this point now we have what? We have the sale plus the intercept, the decimal place 1, 2 plus what is with decimal place, the coefficient with the decimal place of 4, 1, 2, 3, 4. So if we happen to place decimal place here 6, what will happen? It's showing that we are going to have 6 decimal place here, 6 decimal place. Okay, then the mean square error is 2 point and the R square error is 0.9. Now if you look at to conclude on this part, we have what the actual sale and the predicted sale. So it is more better and preferable than the last one, because on the last one we did not have this good value. If you look at on our last, we did not have the value. We have what the sale and the predicted sale. You see, now the sale was 22.1, it predicted 18. The sale was 10.4, it predicted 9. So it was not good. Why is it that it was not good? Because we used but just one. We used but just one variable. That's at this point we use but only the advertisement using the TV. We did not use the sale Look at, we did not use the radio, we did not use the newspaper. So now we use only the advertisement using the TV versus sale. That is why our prediction was not good. But now in the multiple prediction, we use now three of the one, two, three, just to predict only sale. That is why we have a good prediction. Okay. Yeah, if you look at now to conclude, because let us look at our question before we conclude. Our question is telling us that what the business problem is a business problem in this article. So let's consider that the company and it has no input. The company and it has to improve. The company has to improve the sale of a product. The company spend money on different advertisement media such as what the TV, radio, and newspaper to increase the sale of the product. So now the company wanted to know if really they were supposed to use just only TV media or radio or newspaper, or they were supposed to use all. So we say, okay, if they were supposed to use only TV media, it will be a simple linear regression. If they were supposed to use all, it will be multiple linear regression. And now we use now just TV media. We get that they say was not good, the prediction was not good, the price was too poor, so the sale was too poor. So but when we use multiple linear regression, we get that what we have what perfect, because this was for the first one that we use linear for TV, only for TV. If they do only the advertisement for TV, what will be the prediction? It show that now the prediction is show that the sale will be what 18.06. If they use only advertisement for TV, the sale will be poor. If they have it, because this one the sale was 22, but the sale now will reduce. The sale of 10.6 will reduce to 9. But now if now they use multiple of advertisement, now on the sale of 22.1, they are going to have predicted sale of 20.7. Obviously mean that the increase of the advertisement, the various advertisement in various platforms, they will have an increase also in the prediction of sale. So obviously this is correct, absolutely is correct, because in the practical way, when you increase your advertisement, you also increase the sale, so you can sell well when you advertise well. Okay. Yes. So thank you. Bye bye.